We're going to start our discussion of absolute maximums and minimums by looking back at a function that we've already graphed, and that's this cubic function. Now, when we graphed this before, we were doing it so that we could identify intervals on which the function was increasing and decreasing, and that told us about relative maximum and relative minimum points on the graph. So what we discovered for this graph was that we had a relative maximum that happened where x was -1 and a relative minimum that happened where x was 2. We called these relative maximum and minimum points because they were the largest and the smallest points in their little neighborhood. So right around that point, the relative maximum was the highest point and the relative minimum was the lowest point. Now, if you look at the entire graph, which goes from -infinity to +infinity, you'll see that there really isn't any single point that's absolutely the highest point on the graph. And that's because the right arm of the graph continues to go up and up forever. And there's no single point that's absolutely the smallest point on the graph. And that's because the left arm of the graph continues to go down further and further. So if we find an absolute maximum point on a graph, it's the point that's going to have the very largest y-coordinate of any point on that graph. And if we find a point that we consider the absolute minimum on that graph, then that point will have the very smallest y-coordinate of any point on the graph. So if we think about this function, and the fact that its domain goes from -infinity to +infinity, that's why it has no absolute maximum and no absolute minimum, because there are no single points that have the very highest y value or the very lowest y value for their y coordinates. But what if we change the domain of the function? Instead of saying that the domain is -infinity to +infinity, what if we restrict the domain to -2 to +2? Well, now we've got a graph that looks like this. It's just part of the function that we looked at before. And now we can definitely find a point that is the very highest on this graph and a point that's the very lowest. So the absolute maximum value on this graph is 19, and that happens when x is -1. And the absolute lowest point on this graph, the absolute minimum value, is -8. That occurs when x is +2. So by restricting the domain, we were able to identify an absolute maximum and an absolute minimum for this function. What if we restrict the domain a little differently, and we say the domain is from -2 to 0? Well, now the graph would look like this. The absolute maximum value would still be 19, and it still occurs where x is -1. But now the absolute minimum is 8, and that occurs where x is -2. So what you need to notice is that when we're finding an absolute maximum or an absolute minimum, those values are going to occur either at those relative maximum or relative minimum points, or they're going to occur at the endpoints for the domain. So what if we have a function that we would like to find an absolute maximum or minimum value for, but we don't have the graph? How do we do that? Well, if we remember that the absolute maximums and minimums happen either at relative maximums or minimums or at the endpoints of our intervals, we'll be able to find these absolute extrema for the function. So the first thing we'll do is find the critical values for the function. Now that's no different than we've ever found critical values. We'll find a first derivative of the function, set it equal to 0, and find all the values for x that make the first derivative 0. So there's two critical values for this function, +1 and -1. the next thing we'll do is find the value of the function. Find the y coordinates that go along with the x coordinates that are either the critical values or the endpoints for this function. Now the endpoints we're going to have to look at are -3 and 0. And our two critical values were -1 and +1. But stop and think about both of those critical values. Are they in the domain of this function? The domain is now from -3 to 0. And 1 is not part of that domain. So even though it's a critical value, it's not on the graph of this function because the graph of this function only has x coordinates from -3 to 0. So the three values which might be absolute maximum or absolute minimum points are -3, -1, and 0. Remember, -3 and 0 we have to look at because they're the endpoints of our interval, and -1 we have to look at because it's a critical point that's within the interval from -3 to 0. So what we're looking for are the y coordinates of these points, which means we'll take each of the x values and substitute that x value into our function to get a corresponding y value. So we have one point at -3, -12. We have another point at -1, 8. And our last point we need to consider is at 0, 6. The very smallest value in that list, the smallest y coordinate we have is -12. So it is the absolute minimum value on this interval. And that absolute minimum of -12 occurs when x is -3. And the largest value we have for y is 8. So it's the absolute maximum which occurs where x is -1. Now here's the graph of the function, but remember our domain for the function only went from -3 to 0. So it's as if we're only looking at this part of the graph. What we found was that the absolute minimum value was -12, which occurred where x is -3. So on our graph, this is the point that we're seeing. It's the lowest value on our graph. It has the smallest y coordinate. And the absolute maximum we found was 8, which occurred at x equals -1. So it's the point that's the very highest point on our graph, and the largest y value we have is 8, which occurs where x is -1. Let's talk about one last thing before we leave this topic, and that is, how do we determine the domain of a function? Sometimes that's important because we know the function that describes some situation, but because the situation is a real-life situation, there may be some restrictions on the domain, and those restrictions on the domain will affect the values that we look at to find the absolute maximum or absolute minimum of the function. So let's look at this one. Bob sells frozen treats from a food cart every summer. Before he starts selling for the day, Bob fills his food cart with 100 treats, which is the most treats which will fit in his cart. If x represents the number of treats Bob can sell in a day, what is the domain for the function describing his profit? Now, we're not going to actually work with a profit function here. What we're concerned with is, can we figure out what the domain of the function is? Since x represents the number of treats he can sell in a day, he can sell at most 100 treats. That's all that will fit in his cart. And if he has a really bad day, he's not going to sell any treats. So the domain for the function would be from 0 to 100. That means if we were asked to find the absolute maximum or absolute minimum of this function, we would have to consider the 0 and the 100 as possible points where the absolute extrema happen. Here's a different one. A firework is shot into the air and explodes 5 seconds after it's initially fired from the ground. If t represents the number of seconds since the firework is initially fired, what is the domain for the function describing the height of the firework at time t? So now we have to think about what possible values we can have for t. And since t represents the number of seconds since the firework is fired, we know that when the firework is initially fired, the value for t has to be 0. Time is 0. Then the firework goes up in the air, and after 5 seconds it explodes. So 5 is the maximum value for t, which means the domain for the function describing the height of the firework would have to be from 0 to 5. We can't have negative values for time because that would be the time before the firework is fired, and we can't have a value for time greater than 5 because the firework explodes at 5 seconds. So if we were asked to find a maximum or a minimum value, an absolute maximum or absolute minimum value for the height of this firework, we would have to consider the values 0 and 5 as possible values where the maximum occurs. But we'd also have to consider any critical values within the range from 0 to 5. So remember, when we're finding absolute maximum and absolute minimum values, it's important to consider critical values, and it's important to consider the endpoints for the interval that represents the domain of the function.